All right, so hopefully they can join me here. And if anybody has their phone number, you can text them and say, hey, she just posted a Zoom meeting. I don't know what it is with the WebEx down here, but mine doesn't like me.
Put in the Blackboard messages.
I did. Can everybody see my Zoom invitation and Blackboard messages? Just double check me. So far, it's just me hanging out here in my Zoom.
Yeah, I have a link in mine.
What is it?
I have a link in mine.
Okay. I just wanted to make sure. Oh, there's somebody. Hi, Emily. All right, Emily, can you hear me okay? Yes, maybe. Okay. Well, we've got an activity and some of my notes to go over. It'll be mostly in your, starts on like 11.1 eclipses and tides. And I added a few extra slides, but they're just for like your notes. So when I post this, actually I've already posted it, you can see like some of the slides, I just put my notes in for you so that you're not trying to scramble and copy every little thing. All right. So which of the following causes a lunar eclipse? The actual answer is not up there yet. A lunar eclipse is when the Earth casts a shadow on the moon. And that should have just been back at the very first beginning. So this is just like a review. So just relax if it's not a picture. So a lunar eclipse is the only time that the Earth casts a shadow on the moon. It's only during a lunar eclipse. Like this slide is not in your book. But you still need to know that. So what is an eclipse? An eclipse is when something casts a shadow on something else. It eclipses it. So if we were talking, this is the moon casting a shadow on the Earth. We call that a solar eclipse because the moon is eclipsing the sun. It's getting in front of it. When the moon is on the other side, that's a lunar eclipse because the earth is eclipsing or hiding the moon. All right, so what are the two? This is one that I put up for you. So these are my notes. But I wanted you to see the two types of eclipses that we can see from the earth. So we've got lunar eclipses. So you've got sun, earth, moon. When the moon is behind the earth, we call it a lunar eclipse. Then a solar eclipse is sun, moon, earth. When the earth is behind the moon, it's a solar eclipse. Because from the earth, the sun is being hidden. And then from the earth here, the moon is being hidden. And so that's why they call them one a lunar eclipse and one a solar eclipse. So, whoops. Anytime you have light, three things can happen. It can be reflected, just like in a mirror. A mirror reflects light. It can be refracted. Refracted just means to bend the light. Refracted is just bending light. That's how you see a rainbow, when the light is bent. Or it can be absorbed. It can be absorbed by the earth. It can be absorbed by the atmosphere. It can be absorbed by the fabric in your shirt. Just like, so you've got on a dark hoodie. Does it help you feel a little bit warmer outside even when it's chilly? It's because that dark color is absorbing some of that sunlight. So, and now these are, I just included some pictures. So in your head, you can think, okay, what does this look like? So on the earth, some of the sun will hit the clouds or the actual surface of the earth and be reflected back up into space. We just kind of lose it. It can be refracted. So as it passes through raindrops, the raindrops, because you go from air to water, the raindrops actually bend the light and it separates it into the different wavelengths. So Roy G. Biv, that's where that comes from, is just the different wavelengths of light. Have you ever seen a double rainbow? Did you ever realize that with a double rainbow, the top rainbow is inverted? So instead of being Roy G. Biv, it's Biv G. Roy. Because inside that raindrop, when you have two rainbows, light is refracted, so it's bent, but it's also reflected. So you get one that's normal and one that's the opposite. So I just thought that was kind of cool. Or you could have it absorbed. And so we get some light that's reflected by clouds or scattered, some that's absorbed. The earth absorbs about half of the radiation from the sun. And then about 4% of it is reflected. But these are just pictures to help you remember, what is going on with those three things. So with eclipses, we don't just want to talk about light, we want to talk about shadows. The umbra is the darkest part of the shadow. That's where it's just pitch black. It is the darkest part of the shadow. The penumbra is kind of like the gray parts on the outside of it. It's not quite as dark. It's still a shadow, but it's just not quite as dark. All right. So we can have total eclipses or partial eclipses. With a total eclipse, everything is in the umbra. Everything is blocked by the darkest part of the shadow. And that's considered a total eclipse. How many of you got to see the solar eclipse there a couple years ago? Yeah, I thought that was so fun because it was like right at the beginning of school. All right, and then a partial eclipse is when the object is within the penumbra, which is that kind of shadow. Oops. Let me admit everybody. Hi, Lakin. Hi, Scotland. I'm also going to be posting this on the website, the recorded part. All right. So solar eclipses. Skip the viewing part. Yes.
So the Zoom you have going right now is only for people that can't come during this time that are normally this time, right? Like you're still having the 12 to 1?
Yes.
Okay. Girls that are in the 12 to 1 are messaging me because they thought you sent that link for all of us to meet online. So that's why they're joining.
I'm so sorry.
No, it's okay. I'm telling them.
Tell them they can hang out here if they want to.
Okay.
Then... No, if I send you a link, it's almost always if I've got kids who are sick. Or at least been exposed. Hopefully nobody was at Nutter Ford Elementary last week. Because it is shut down tight. So solar eclipses, you guys, Lake and Scotland, you guys can stay here if you want. Well, Scotland disappeared. But you don't have to. So the solar eclipse happens about 5 times a year. We don't always see it. Like it is not always visible from North America. In fact, the next one from North America isn't until I believe it's 2024. It's supposed to be a huge one. So I'm excited for that. But they only last 7.5 minutes. A total solar eclipse, those are different. That is when umbra. Oh, is somebody else coming? No. That's when the umbra covers the sun. And like I said, the next one is going to be in 2024. So the path of totality in that picture, that just shows like where you can see a total eclipse. And then this shows like wherever you are, you can see it a little bit different, but there's only about 270 kilometers that an eclipse is visible. So they're pretty rare to see a total one. Obviously, never look at the sun directly. Use a pinhole camera or a sun spotter. What's really fun with little kids, because you guys will be teaching the next time there's an eclipse. Use a colander or a strainer and just have the kids look at the shadows on the ground. And you will be able to see the eclipse in every little tiny hole that's in your colander. And they can see it, the shadow move across. It's really fun for them. And plus, That way they're not looking up. Oops. All right. So an annular eclipse, the moon is at apogee. Remember where we talked about aphelion, perihelion? So apogee refers to the moon being it's far away at its furthest distance from the earth. Now, because of that distance, the umbra doesn't reach all the way to the earth because it's small. It's only 1/6 of the size. And then this is what it would look like. You'd still have like the ring of the sun surrounding the moon. Oops. Stop. All right. So if you've ever seen a lunar eclipse, you will notice that the sun has a very red glow to it. Very, very red. Does anybody know why?
Isn't it like the Earth's shadow? Because like the Earth is casting a shadow into it, so the sun would be shining.
You're close. You're very close. You're right. So the sun is going to be going at a long angle through the Earth's atmosphere. The longest wavelength of light is red. And so that's the only wavelength of light that's going to be reaching the moon to reflect back. Everything else is going to be scattered. And so because the moon is at such a low angle, only the really low wavelengths of light are seen. And that's the red wavelength. And it's just because of our atmosphere. If you've noticed, we've been having really pretty sunsets. It's because of the wildfires in California. All of that debris is now, it's all over the world now in our atmosphere, and it scatters the light in the evenings. And so we get really, really beautiful reds, pinks, yellows. And so it's the only good thing you could say about those wildfires right now. All right. So lunar eclipses happen twice per year, and they last for several hours. I guess it's a couple hours. It feels longer when you wake your kids up to come and watch them with you. And they're tired. Whoops. Oh, shoot, and I can't go back. Okay. So why does the moon appear red? I want you to jot that down. Anybody need me to repeat it? I know everybody looks very tired today. It's like that weekend just flew by. The sun's angle is very low in the sky. As the light passes through our atmosphere, only the long wavelengths are reflected. In parentheses, red. Mm-hmm. As the light passes through our atmosphere, only the long wavelengths are reflected, and that's red. So why don't we have a lunar eclipse once a month? Lacey? Think about the tilt of the orbit of the moon. What degree did we say that the moon orbits the Earth? It's about 5%. The Earth itself is tilted at 23.5. The tilt of the orbit of the moon is at 5%. So it's at a 5-degree angle. It's just at a 5-degree angle in its orbit. And Ketu and Rahu, this is where the moon is like close up to some of its closer points. And Egyptian myth used to call it the nodes of the lunar nodes. And so there were myths associated with that. And that's what they referred to the moon as when they could see it closer to the Earth. You don't have to know that. That was just for your information. All right. So the tides of the Earth. What causes the tides? Yes, there's a tug of war between the sun and the moon. Which has a greater effect on us? Lainey? Yeah. Yeah, the moon. And that's only because it's closer. Because it is so much closer to us than the sun. So oh, you're killing me too. I'm sorry. That's okay. The sun is, 1,000,000 times larger, but it's too far away to have a huge effect. And why are they spaced roughly 6.5 hours apart? So you have a high tide, then 6.5 hours low tide, and then a high tide, and then a low tide. So 4 times 6, roughly what? All right, so roughly 24 hours, and that's all due to the Earth's rotation. All right, I'm going to yes.
I was going to say, I watch this animal show a lot, and it was basically saying that the moon plays the biggest part in the food chain, and no one realizes it because animals like to hunt at night, and depending on the moon phase, they can't see. So it was saying that, I think the example was cheetahs, they go out and hunt at night, and the pigs and stuff are able to reproduce certain days of the month because they can't see them, but certain
Oh, like during a new moon.
Yeah, a certain phase of the moon is when they eat a lot of the different animals. It's weird.
That is really neat. I've never even thought about that.
Yeah.
So these are my notes for you. We're not going to spend time reading over this. This is just my notes for you, and it will be posted. I do want you to understand the difference between a spring tide and a neap tide, N-E-A-P-E. So when the Earth, moon, and sun are all in alignment. So remember, that would be at a new moon, where it's sun, moon, Earth, or at a full moon, where it's sun, Earth, moon. Those are the biggest tides. You have really high tides, really low tides. And those are known as spring tides, not like it's more like a spring, like that, instead of, spring, flowers, no. The other kind of spring. And I have a picture coming up. And then neap tides there's hardly any difference between high tide and low tide. It's just kind of all that slack water. That's when it's at a first quarter moon or a third quarter moon. So when they're at 90-degree angles, there's not as much tug of war going on. So the tides are pretty even. Low tides kind of normal, high tides, or low tides kind of high tides kind of low. So there's not a whole lot of difference. And those are called neap tides. So when this gravity affects the earth, it doesn't just affect the oceans. It actually pulls on the earth as well. Did you know you even have tides in the Great Lakes? Any large bodies of water will display tides. The smaller bodies of water, you just can't see it as well because there's not a big enough bulge like there is in an ocean. So tides are called diurnal. Diurnal just means twice a day. So 2 high tides each day, 2 low tides each day. What else do we refer to as diurnal? Any animals that are up during the day and sleep at night. Whereas nocturnal is the animals that are awake at night and sleep in the day. That's rough. So what happens to tides when the sun, earth, and moon line up? And this is what I was just talking to you about. When they line up, that's when we call them spring tides. Extra high tides, extra low tides. And again, with the first quarter and the third quarter, let's see here. Lacey, why is my first quarter on top and my third quarter on bottom? Because what? I think you just said it.
Where the sun is.
Exactly, because the sun's on this side. So remember, on that next test, you have to be able to switch those things around. So anytime the moon and the sun and the earth are at 90-degree angles, we have neap tides. It just means they're kind of moderate, barely any difference between them. Gosh, makes me want to be at the beach. All right, and then I'm going to just kind of push through that because that's just a picture for you. Okay, so the change in tides when the tide is coming in, it's called a flood current. When it's moving from low to high, we call it a flood current. As it is going out from high to low, we call it an ebb current. And then those few hours in between, just slack water. If you've ever been in the sound when tide's coming in or out, you can really feel it there, especially if you're kayaking. I try never to go kayaking in the sound down in North Carolina where I go when the tide is going out. I'm like scared to death I'll get like out in the open ocean. I would not want to be there. All right, so tides are affected by the sea or the oceans, the bottom of it. For example, how many of you been to both the Atlantic and the Pacific Oceans? The Pacific Ocean is rough. It is very rough. And so that's why you have a lot of good surfing on the West Coast. It is, the bottom of the ocean is like deep valleys and stuff. And so it changes the way the waves hit. The Bay of Fundy, Dr. Deb and I went, well, we've been all over the United States together, but we went to the Bay of Fundy together. I don't know what class we were teaching at WVU. And this is crazy. So 15 meters, you're talking roughly 75 feet difference when it's like low tide. No big deal. They have a siren to let you know to get the heck out when that tide is coming back in. And there are all of these ladders that you have to climb to get out. And it fills up 75 feet. You know, just, it's fast. And so those places like that are crazy. And then if you're in the open ocean, that's someplace I've never been deep water. There's only about a 3-foot change in the waves. On the coast of California, though, between low tide and high tide, there's 6 feet difference between, you know, the size of the waves. So what would happen to the Earth's tides if we didn't rotate?
Well, what if they only be on one side?
Okay.
It'd just be on the side where the moon is.
What is it?
It'd just be on the side that the moon is, like wherever the moon goes, that's where the tide is.
Well, but doesn't the moon is still going to revolve, even if we didn't rotate? So they'd probably last longer. So we'd still have tides, but they would last a lot longer. But what would happen to the tides if we didn't have a moon? Would we still have tides?
Maybe a little bit tiny.
Yeah, little baby tides. Whoops. Yeah, we'd have very little tide because the sun doesn't affect us that much. And finally, which eclipse occurs when the moon passes through the penumbra? Total eclipse or partial eclipse? Karis?
Partial?
It is partial. The way I remember these, penumbra, partial, PP. I'm going to stop that part for the day because you can read the rest of it. And we are going to start a real quick activity. I do want to remind you, do not come to this classroom on Wednesday. Do not try to log on to Zoom to anything on Wednesday. You will not find me. I shall not be here. I am doing SAT testing for 5 hours that day. Here you go. So, the 3 of you on the front row are together. You 3 are together. You 3, you got nothing. And you 3 are together. All right. So before you do anything, I want you to look at all of the items that you could have with you if I put you on the moon. I want you to rank them. Number 1 is, oh, I have to have it. And I think it's all the way down to 15. Please, it would be useless to me. So by yourself, before you talk to anybody, rank these items and don't change them just because your group might change them to something else. All right, Emily, Lakin, whoops. Let me unmute you. Can you guys both unmute yourselves?
Yeah.
All right. So this is posted on today's assignments, and it's just called Lost on the Moon. You can do it on your own paper, and you can just do it individually. Because basically it is a participation, because I don't expect you to all know everything about the moon quite yet. Does that make sense?
Yeah, I printed one before I left my house this morning, so I'm looking at what you're looking at.
Okay. All right. And then once you guys get your individual down, anyway, then you can start talking with your group to figure out what you and your group want to use. All right, Lakin and Emily, I'm going to go ahead and stop recording now. And you can simply take a picture of your Lost on the Moon, if you're doing it on a sheet of paper, and submit that to me. And I'm going to post the NASA rankings for you guys to check yourself, okay? I hope you guys stay well. And don't forget, there's no class meeting on Wednesday. Hey guys, before I forget, on Wednesday, I've already posted, you're going to do like the moon hoax, which a lot of people still argue that we didn't really go to the moon. So I'm going to show you the Fox News special from 2001. And please remember that we really did go to the moon, but I'll show you how easy it is for people to say, really? And so you'll have to watch that. And there's like an assignment that's due with it where you find, and I'll send you some good links because I think the links that are on Blackboard might be dead.
That's Wednesday.
Yeah. So yeah, you're not going to come here. You can really do it anytime between now and next Monday.
Okay.
Bye, guys.